All right, let's take a look at an economic or business application of calculus derivatives. So a music store sells an average of 120 music CDs per week at $24 each. A market survey indicates that for each 75-cent decrease in price, excuse me, 5 additional CDs will be sold per week. The cost of producing X music CDs is C of X is equal to negative 0.003x squared plus 4.2x plus 3,000. Determine the marginal profit from the weekly sales of 150 music CDs. Okay, so first we need to define that profit. Let's say P of X, their profit function. This is equal to the revenue function minus the cost function. Okay, now we're given our cost function. We need to find a revenue function. Now the revenue function is equal to the quantity that's being sold. That is defined by, let's use Q of X to represent quantity of X units sold, minus, times, okay, let's use a generic multiplication sign. It's times the demand function. The demand function will tell you the unit price, right? So this is kind of like quantity sold, and this is the unit price. Right, and this is a revenue for the number of units or X units sold, okay? Now, in this case, we can understand that if we looked at our quantity function and our price function, so if we looked at our revenue function, quantity and price, okay, our quantity function, we can understand here that 120 music CDs are being sold at a price of $24 each, okay? But then a survey tells us that for each 75-cent decrease in price, right? So if I decrease the price by 75 cents, you're going to get 5 additional CDs being sold, right? Just general principle of demand and supply. So you can notice here that X is the incremental decrease in price, and here that's correlated or that's associated with X, which is the incremental increases of the quantity, right? So each time I decrease the price by 75 cents or 0.75x, I increase the quantity being purchased by 5x. Okay, so that kind of makes sense in an economic demand and supply intuitive way, right? So we can understand that if the price of a good goes down, customers or consumers will tend to purchase more of that good, right? So this is your revenue function. Okay, so now we have our revenue function, we have our cost function, and we can look at this one of two ways. Now we can understand that the profit function is revenue minus cost. The marginal profit function, which is the first derivative, let's take a look at this. The marginal profit function, which is the first derivative of the profit function, and basically highlights the profit that is being created per unit of goods sold, produced and sold, right? So the marginal profit function, which is the first derivative of the profit function, is the derivative of the revenue function, which is also known as marginal revenue, minus the derivative of the cost function, which is also known as marginal cost, right? So this is the revenue per unit of good produced and sold, and this is the cost per unit of good produced, right? So in this case, let's find the individual derivatives of each function. So let's find the marginal revenue function. So if I look at the marginal revenue function, I'm just going to use the product rule really quickly, right? Because you're multiplying what looks like two different functions. So I'm going to do the derivative of the right-hand factor plus 5x, the left-hand factor, so the factor on the left, times 24 minus 0.75x plus the derivative of 24 minus 0.75x times 120 plus 5x, okay? So if I take the derivative of 120 plus 5x, you get 5 times 24 minus 0.75x plus minus, because we're doing the derivative of negative 0.75x, so 0.75, right, times 120 plus 5x. Okay, so this is your revenue function, and if I simplify out the revenue function, you get 5 times 24 is 120 minus 0.75 times 5, which is negative 3.75x minus 120 times 0.75, which is 90, minus, once again, we get 3.75x. Okay, and I'm going to collect all the like terms. So the marginal revenue function here is 120 minus 90, so that's 30. Minus 3.75 minus 3.75, which is minus 7.50x. Okay, so that's your marginal revenue function. Your cost function is given. It's right here, right? So the marginal cost function, c prime of x, I'm just going to do the derivative of that. So you get negative 0.006x, right? So you're just using power rule. 2 times negative 0.003. Subtract 1 to the power, plus 4.2. So you can see that the marginal profit function is this marginal revenue minus marginal cost, right? So we get 30 minus 7.50x minus negative 0.006x plus 4.2, kind of ran out of space there. And the marginal profit function here is 30 minus 7.50x plus 0.006x minus 4.2. And your marginal profit function here, and if I combine all the like terms, right, we get 25.8 minus 7.494x. Okay, so this is our marginal profit function. Okay, and what producers will do is they'll tend to produce until their marginal profit will reach 0, right? And we can understand that if the marginal profit is greater than 0, that means that the marginal revenue per unit that is being sold would be greater than the marginal cost, right, or the cost per unit being sold. And if the marginal profit is less than 0, then the marginal revenue is going to be less than the marginal cost, right? And if it's equal to 0, then these two, the marginal revenue and marginal cost, will be the same. And producers will produce until they reach this point, and then beyond that point they'll stop producing. This is just to maximize